Hi everybody! So in our next video, we're going to review the last little bit of stuff that has to do with what we've learned in semester 1. And this is going to be some stuff that doesn't really fit nicely into one specific category, or maybe was sort of something that was sort of separate from one of the categories of ideas that we've already reviewed. So we're going to start today by reviewing how to find slope. When you have a graph, slope is just rise over run. So that's one way that we can find slope. But another way to find slope, if you don't have a graph or if you have two ordered pairs, is y2 minus y1 over x2 minus x1. Now, when I'm going to do this in this example, I prefer to label the ordered pairs. So I'm going to have x1, y1, and x2, y2 before I start. I think that makes it a little bit easier to fill everything into the formula. So if I was to fill those numbers into the formula, I would have y2, which is 5, minus y1, which is 3, over 1 minus negative 2. Which means I'm going to get 2 over, and then these two minuses together make a plus, so I get 2 over 3. Now, if I were to give you a graph like this one and say calculate the slope using units, then what I would do is this rise over run, because I've got a graph this time instead of ordered pairs. So I would do rise over run. Now, I can pick any 2 points that I want to figure out the rise and the run. So to get from here to here, I would go down 1, right 2. So I would write negative 1 over 2. And then I need to include units. So if I look at my rise units would be the ones that are on the vertical axis. So I would say gallons. And my run units would be the ones that are on the horizontal axis. So I would say per hour. In addition to learning about slope, we also learned about types of numbers and how numbers come in different categories. So we said all the numbers that we're ever going to learn about are going to be the real numbers. But within the real numbers category, we have the rational numbers and the irrational numbers. Now, an example for rational numbers would be decimals and fractions and positive numbers and negative numbers. And examples of irrational numbers would be like weird numbers like pi, which is kind of a weird number. We have a number called e, which might be a weird number. We could say ugly square roots belong in here, like the square root of 7 would be kind of an ugly number, doesn't really fit nicely into a nice number. Within the rational number category, we said there were two subgroups. So we've got the integers, and within that category, we've got the whole numbers. Now, the only difference here is that integers can be positive or negative, and whole numbers can only be positive, nice round numbers, so no decimals. An example of a problem that involves domain and range is, so we should probably review domain and range first. Domain is all the list of the inputs or the x values of a function, and range is the list of all the outputs or the y values of the function. And an example of a domain and range problem would be if a basketball stadium can hold up to 23,567 people, and we know they earn revenue using this equation, where x is the number of tickets sold for the game, what is the domain of the revenue function? Since domain is asking me about the x's, and x is the number of tickets that I sell, I need to ask myself, can I sell a negative number of tickets? The answer is no. Can I sell a decimal number of tickets? So can I sell like 2.5 tickets? The answer is no. So is there a max or a min? Well, since the capacity is 23,567 people, that would be the maximum number that I could sell. So what I would say is that the domain, by combining all of those things, would be no decimals, no negatives. So I'm looking at just the whole numbers that are less than, because this is going to be the maximum that I can sell, 23,567. Another thing that we learned about was a special notation for functions. So we said function notation looks like this. In function notation, any numbers that are inside of the parentheses are always x values, and any numbers that are outside of the parentheses are always y values. So if I give you this function and I say figure out what happens when x is 3, then I would replace the number on the inside of the parentheses with a 3. So I plug the number 3 in for the x. I also plug the number 3 in for this x. And when I simplify this, I figure out that f of 3 equals, 3 times 3 is 9 minus 5 is 4, so f of 3 equals 4. And what this means is that when I plug in 3, I get 4 as my answer. Now, if I give you this, for example, where it says f of x equals 7, this is going to be a y value, because that's outside of the parentheses. So what I would do is I would replace the whole thing on the left side of the equal sign with 7. So 7 equals 3x minus 5. And then I would solve this. So I would add 5 on both sides. And I would get 12 equals 3x. And then I would divide by 3. And I would get 4 equals x. And there we go. We only have a few more things to review. I hope this is helping you kind of remember some of the other stuff that we've learned. After we learned about function notation, we said sometimes we have things that are not functions. And so the trick for remembering was this, which is that everyone can only go to one party at a time. So, another way to remember this was what we called the vertical line test. And we only used that test when we had a graph of our equation, our function. So in this first problem, if I look at the inputs, 2 is going to 4's party, negative 8 is going to 0's party, but 1 is trying to go to 2 different parties, which is not allowed. So I would say that this is not a function. In the second picture, if I draw a bunch of vertical lines, I can see that every time I draw a vertical line, it crosses the graph more than one time. So I'm trying to go to too many parties, so this is not a function. If I look at the next example, 11 is going to 3's party, 6 is going to 5's party, 7 is going to 1's party, 9 is going to 7's party, 8 is going to 3's party. Since everybody's only trying to go to one party, I would say that this is a function. The last thing that we learned about functions was how to find some function values when you have a graph. So if I give you this graph and I say find f of negative 8, then that means that I look for that number on the x-axis, because that is an x value. So if I go to the negative 8, the y value of that number is 4. If I look for where x is 4, because again this is an x value, the y value of that number is 6. Now in the next problem it's a little bit different because now this is a y value. It's on the outside of the parentheses. So if I look for the negative 2 on the y-axis, the x value is 3. And if I look for the y being a 6, the x value would be 4. I hope this helps you review a little bit about some miscellaneous kind of stuff that we've learned, and I will see you tomorrow in class for some more practice. Here we go.